All right, so here's another problem about decomposing angles. Let's read our problem and make sense of it. Waylon and Andres play a game where the goal is to fill a tray with 3 same-size triangular game pieces. Triangular means they are triangles. There are no gaps and no overlaps. What is the measure of the bottom angle of the tray? All right, so what is this problem about? Let's just picture it in our brain. We've got 2 people, Waylon and Andres, that's the who. What? They're playing a game. Where? Don't know, doesn't really matter. So it's about Waylon and Andres playing a game that has, the goal of the game is to fill a tray with triangular pieces. All right, so close your eyes. Picture these 2 boys, Waylon and Andres, playing a game. They're holding triangular game pieces. The goal is to fill a tray. All right, that's what's going on. We're going to read the problem again. Waylon and Andres play a game where the goal is to fill a tray with 3 same-size triangular game pieces. There are no gaps and no overlaps. What is the measure of the bottom angle of the tray? All right, what are we trying to find out? What is our goal in this problem? Well, our goal is the question. And the question in this problem is, what is the measure of the bottom angle of the tray? All right, so that is our goal. That is our question. Let's read our problem again. Waylon and Andres play a game where the goal is to fill a tray with 3 same-size triangular game pieces. There are no gaps and no overlaps. What is the measure of the bottom angle of the tray? All right, what important information do we have here? Well, it is very important that we know that all of these pieces are the same size and that they are triangular. If these pieces are all the same size and they're all triangular, all 3 pieces have the exact same what? Exact same angles. Okay? If you have 3 triangles that are the same size, all 3 of those triangles have the same angles. All right? It's also important that we know that there's no gaps or overlaps, because that way we know that the angle that all 3 are making together is truly the sum of one piece 3 times, because it's not overlapped or gapped at all. So that's very important to know that. All right, so how are we going to solve this problem? Well, the information also that we have that's very important, one game piece has an angle of 50, all right? One of these game pieces has an angle of 50 what? 50 degrees, all right? So if we know that one game piece has an angle of 50 degrees and 3 of these game pieces are being put together to create one larger angle, what should we do to figure out the sum or the measure of the bottom angle of the tray? Well, I kind of just gave it away, right? I hope I did. I said sum. I need to find the sum of 3 of these in order to find this angle. What operation are we going to use? That's right, we're going to use addition. Or we could use something else, because we have 3 of the same size pieces. We have the same number 3 times, so we could use multiplication, all right? Either one. So we could do 50 plus 50 plus what? We have 3 of the exact same pieces, so it's going to be 50 plus 50 plus 50. How else could I solve this using multiplication? If I have 50 added together 3 times, I could do 3 times 50. Okay? Either one of these equations will solve this problem. All right? So you can go ahead and use your calculator or work this out on a piece of paper. Either one is perfectly fine. You should be able to count by 50s. If you can count by 5s, you can count by 50s. Go ahead and solve this problem. Take a minute. Pause the video if you need to. And our sum would be 150 what? 150 what? What's our unit? Degrees, don't forget. Or 3 times 50 also equals 150. 150 degrees. All right? So if we are answering this in a full sentence, what is the measure of the bottom angle of the tray? The measure of the bottom angle of the tray is 150 degrees. All right.